Okay, I wanted to take a second and kind of go through the code for the simplex algorithm stuff we were doing in R. And what I wanted to do is actually just look at the, so in the, if you look here, there's an example, right, an example that you're going to run. And I'd like to kind of use this example and talk about what's going on. And then actually go through what's happening in the code. So I thought this would be a good time to do that. So let me talk through stuff. If you'd watched the other videos that were posted, we have what we want to do is we want to get this what's called simplex tableau, right? The initial tableau here for the simplex method, and the setup, right, the very first part of the code is actually just a setup for this tableau. Okay. So notice, right, here, this is my constraints, right? Right, in the code, it's just, I think it's const or something like that. So what I want to do is I want to take the constraints, right? And then what I want to have is underneath that is the objective function. Right? Now notice this is a negative objective function. Right? This is something to keep in mind. Because really, I mean, when we think about what's happening, if if I'm maximizing or minimizing like z, right? And it's kind of, we just put some variable over here. We'll say z, maximize z subject to these constraints. But if we're saying z is equal to, I don't know, some, right, a x1 plus some, right, bx2, right, in this case we're doing this negative 300, or the 300 and 200 would be here. Well, if I want to get them all, right, notice this is like negative 300, negative 200. This variable, right, here, this variable you see right here, this is actually z. Right, we can think of this as the z. Right, it has a 1 and there's a 0. So what we're saying is that we're pulling all of this from the right-hand side, right, subtracting it here, right, subtracting this. And so you'll notice that what we'll get is like a z minus ax1 minus bx2 equals 0. Right? Equivalent way of writing that, right? Just with some very simple algebra. So that's why we're using the negative of the objective function. Here we can think of this as my x1 variable, right? This is sort of my x2 variable. And then these here, right, this, I'll write it under there because I have something under there. This is a slack variable, right? I'll call it S1. This is my second slack variable. I'll call it S2. And then I have Z, right? So then I have my Z right here. And so you notice that in this case, these variables are actually x1 and x2 are both 0. If you remember kind of the geometric setup, we consider x1 and x2 to be 0. Then these are my these variables right here, right? The S1 and S2. So like S1 is 180, S2 is 135, so on. And so let's actually go through and see if we can do this, right? So we, the first part what we do is we're sort of like, I think of it as like gluing or sticking the negative objective function on the bottom of the constraint matrix, right? Then we're going to make, it looks like if you look closely, right, this whole thing right here, this is just an identity matrix. So I'll sort of like stick the identity matrix on the right side, and then for the last step, what I'm going to do is I'm going to take that right-hand side, right? This is the right-hand side. I just put a 0 on it and then stick that to the right of that. Okay? So this is the plan, right? This is what we're going to do here in the code. And sometimes when I'm actually writing this, I may want to do things in in this little console down here, right? The console allows me to do a little bit of well, it'll allow me to do a little bit of scripting before I actually put it into the actual R script up here that I want to use. So let's see. It says first step, set up the tableau, right? So we're going to use rbind. Rbind is a function in R. And if you're curious of what's happening here, we can always try it out, right? I can just say co rbind. And what we want to do is we want to take our constraint matrix and put the negative objective matrix, or the negative objective thing on there, right? And so if I want, I can see what CO looks like, right? So notice that looks really close to what we actually are getting to, right? So this is what our goal is, and so notice that that left part is we're pretty much, you know, good to go, right? So in here, right, what I want to do is I want to take away these @ signs. I'm going to do objective function, and then, I'm sorry, this is constraint, and then negative objective function. Now, what we're doing here, I want to make a, my goal here is to actually make an identity matrix. And the way I'm going to do that is by actually figuring out the number of rows in this matrix. So I mean, if you hard code in like 3, because this one is just 3, well, that's not really going to be very helpful for like a larger problem. So maybe you want to put in a larger problem, or maybe, you know, you want to put in whatever sized problem it is you want to do. So by doing this, what we're actually going to be able to do is put in any size of constraint and objective function, and what it'll actually do is give us the answer that we want. So if I get the dimensions of the CO matrix, and now if I say numRow is dims1, right? And if you're curious what's going on here, if I just do dims of CO, oh, I'm sorry, dim CO. Right, put an S on there because I call it dims. Notice that what it's storing here in this dims variable is this little vector thing. It's a 3 and a 2. So 3, this is the number of rows, and 2 is the number of columns, right? So it's telling me that the dimensions of this matrix CO is a 3 by 2, right? So here for the number of rows, right, I can just say numRow is, I want to store that, and that's going to be dims1. So I'm just pulling the first value on here, right? Now, it says add an identity matrix to the right of the matrix CO, right? These are going to be the slack variables and that Z variable that I showed in there, right? So what we're going to use is something called cbind. So I'm going to do cbind, and I'm going to do CO, and then diag numRow, right? So if you want to see what's happening, we can go, we want to do cbind, right? And I'll store this so we can use it later. I'll do the same thing that's going on there. So I'll do cbind, there's CO, and that's going to be diag. I'm just going to write 3 because that's what we actually want to do here, right? And if you want to see what this looks like, right? Well, we're in pretty good shape, right? We're getting really close, right? This is our goal, right? The last thing we have to do is put the right-hand side on, right? And that's what we're going to call tableau, right? I'm just going to call it T for right now. And notice once again what I'm going to do is I'm going to do cbind again. I'm going to put M, and then what I actually have to do is put a 0 onto the right-hand side, right? So this is how I'm going to do that, right? And ta-da, right? Exactly what we wanted, right? So for Tableau, I'll go back up here and make sure I do that, right? So this I'm going to use cbind, co, I'm sorry, not com, and then I want to do the right-hand side along with a 0. So there we go. Now it's just saying to print it, right? And there we go, right? We're good to go. Now it says get the dimensions, once again, of this new thing, the Tableau. We'll need the columns later, so why not just pull it? Why not just pull it now? Right. Dims Tableau, and remember columns are stored in the second. Create a negative indicator for the last row in the Tableau. If there are no more negative entries in the row, then the algorithm is finished, right? This should be initialized as a logical variable with the value true. Right, so boom, there it is. Right. So this is just a quick check to see if it's actually false. Suppose you could put it in here, your if statement. You could do an if this, right, neg indicator equal false, right, else negative indicator is equal to true. So it's just a quick check to make sure. Now, this is where the bulk of the algorithm actually begins, right? We haven't done any of the simplex algorithm yet. So really we want to do while the negative indicator is true, or while it's still there, and you could say while neg indicator equal true, or equal true, double equal true. I'm just going to say while neg indicator, okay. Because notice that if it's true, right, I mean the while statement really only cares when things are true or false. So if it's true, it's going to keep going, right? If it's false, it's going to send the, it's going to jump out of the while loop. Right? So what are we going to do? Well, we're going to get an index for the pivot column, right? So we want the most negative number in the last row. So this, right, you don't have to do any, you don't have to really touch anything here, right? This is just doing the which.min, right? And it's going to be which.min Tableau, right? The row is the number row, the number of rows, right? So since we have 3, right, we have 3 rows, what it's going to do is it's going to pull that row out. It's going to find the, it's going to find our, let's say, largest negative, right, or our, right, and then it's going to extract, it's going to give me that index value, right. So then what I do is I get my pivot column, right, extract the pivot column except for the last row. So then we're going to put that variable in pcall. So which what do I want? Well, I want to take everything, right, from so I want to take the first, second, third, all of the entries up to the last one. I mean, for our table, I mean, really, if you look at what's happening, this is the table that we made. The table is like down here, right? It's going to go and find this one, right? It's going to find where the negative 300 is. And what I want to do is just pull the 5 and the 3 out, right? So this is my column. The reason I don't want the last row, it'll be, I'm going to have to do some division, and I'd be dividing by zeros, and so I don't want to do that. So what I can do is go from 1 to, we'll say we called it numRow -1, right? And right, so that's the rows I want. And what column do I want? Well, I want the pivot column index, right? So pcol index. Right? And I found that up there. If there are no possible pivot rows, right, if all pivots are equal to 0, then right, we want to say that it's Tableau. That this problem is actually unbounded and no maximum is possible. All right. So if all pivot column entries are less than 0, then then what I want is to actually stop. Right. So how are we going to do this? Well, if I have like let's see. If I have this, I can say something like if right? Because I have my pivot column. Then I want to print the problem as unbounded and no maximum as possible. Okay, so next I want to get the pivot row. This is 6 of the flowchart. First, what we're going to do is we're going to find the rows in which the pivot column has positive entries. Right? We want to call these possible rows. So in this case, right, possible rows is a vector of row indices. So I want to do which, right, pcol, right, greater than 0. Right. So this is going to give me the rows that I can use from there. Right. Now it says select entries from goodness. Select entries from the last column in these same rows. Okay. So what I'm going to do now is I'm going to go and find the rows, which are going to be possible rows. Right? And the column is the last column. So we've stored the number of columns, right? And if I just pass in numcol, that should actually do it, right? Because if there's, I don't remember how many columns are in the table. Let's see, 1, 2, 3, 4, 5, 6, right? So the number of columns is 6. So if I actually give it the value numcol, 6 is stored in here, so it's going to give me the list of the row entries, right, and then everything from those rows in the last column. Right? Now what I want to do is I want to divide this by the possible rows from the column index, right? So notice here what I'm going to do, right, is get this division, right? Now I want the min, right, the min of these possible rows, right? Find the index of the minimum calculated ratio. So I want to do which.min, right, and this is going to be div. Right. Now I have my p row index, right? So that's possible rows, right, of min pos, right, whichever one returned there. So now the pivot value is actually going to be, right, my p row index and my pcol index. Okay. am I going to do here? Right, I want to obtain the pivot value and divide the pivot row by the pivot value. Right. So notice what I'm going to do here is I can either do 1 divided by the pivot, so 1 divided by pivot times this. Right. So this is going to give me that whole row. Right, because I'm pulling the whole row out, I'm dividing the whole row by the pivot, and I'm putting that back into the tableau, right? So the value at wherever our p-call index, p-row index was, right, our pivot value, that's now 1, right? So now all we have to do is clear values in the pivot column above and below the pivot. So in this case, what you're going to do is you're going to take the row, right, and you're going to take the and just loop through this, right? Right, so we're going from 1 to the number of rows, right, and I'm saying for rows in these, all of these, here if row not equal p-row index, right, because we don't want to do this for the row, otherwise it'll do something very weird. We're going to take the row, we're going to subtract off, right, this -1, right, times this, times the tableau p-row index, right? So what I want to do is I want to take the rows, right? Like essentially what we would do is like we'd start here, we'd figure out, right? This is my pivot column, right? Then I do the division, right? Find what's the, I think it's going to be this one, right? I think. Right, so find the one that's going to give us the sort of like the best one to go for, right? And then notice if I divide everything by 5 in the row, that's fine. And what I want to do is I want to clear the other thing. So what I'm going to do is I'm going to take this, I'm going to take this row, right? So like let's say this row, right? I want to get this turned into a 0, right? So what I have to do is I have to go down the pivot column, right? I have to multiply by a negative of this value right here to get rid of it. And remember the 5 is turned into a 1, so if I want to get rid of the 3, I just multiply this by a negative 3. So let's go back and try that. So here I'm taking that row, right? I'm doing a negative of the row, right? And where do I want? It's going to be p-call index, right? So that's the thing, right? And it's going to be multiplied by the p-row index, right? And I'm going to add it back in. We'll keep going until we're done, right? So each time this happens, we're going to print the tableau out and take a look at it. Right. Right. If, right, then negative here. It's false. And then it's going to do that, right? And at the end, we're going to return the tableau. Right? So let's see. I'm sure I made a mistake somewhere, but let's try running this, right? Load this in and see what works here. Okay. Now what I want to do is I want to take my, I want to go here. I'm going to try to run this. I've already loaded in the objective function, the constraints, on the right-hand side. Remember, we were looking at those earlier. And so now I'm just going to paste this in, run it, and see what it does. Probably give me an error, yeah. The condition has length greater than 1, and only the first element will be used. Okay. Okay. What did I do? I messed that up. Oh, there we go. Let's see what I did. I completely forgot this if max. We'll fix the problem now. If max. Okay. Now I will rerun it. And there we go. Right. So notice that it printed out our initial tableau, right? The next thing it does is, like, inside the loop, once it's done, it prints it out. So notice what we did is we took that, right? We cleared out this, right? The next thing we do is we got this one, right, and cleared this out, right? And so then this is the overall, this is the final one that it prints out for the, right? But there we go, right? So there's a very basic overview of the simplex method and the R code we were writing for it. All right.